We are trying to go for setting some standard in the normal distribution. That's what we call it as a standard normal variate. If you try to go for -2 standard deviation from year to year, the area is covered for 95.44%. The formula expressed by rating 180.4 minus mu is given in the question 200 divided by 10. If you subtract, we are getting 19.6 divided by 10. We are getting 1.96. Again, we need to refer the table. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 3, Section 11, third semester BCom, probability distribution, and today my agenda, normal distribution or normal curve. In the previous session, which is related to binomial and Poisson distribution, now moving to normal distribution. In the normal distribution, the most of the area they are using common distribution they are using, so which is very common for almost all the field. So here many observations such as height, because whatever we studied the two distribution in the previous session, which is related to discrete series. Now we just for going for the continuous series. So when continuous series, when there is a lower limit and upper limit like this, okay, and we are able to identify there is a range. So in this observation, okay, many observations such as height of the some soldier and IQ of a group of children, which is related to continuous series, because in between we are trying to find out the range. So the body temperature of the some patient and rainfall in a certain area and variety of many other phenomena are known to follow the bell-shaped curve. The bell-shaped curve means actually in the normal distribution. So when it is equally distributing, now seeing the graph only we can understand which is looking like a bell-shaped curve. Okay, so here left tile, you can say here left tile and right tile will be always 0.5. The total bell shape, the total area is always equal to standard deviation is equal to 1 here. Okay, and mu is equal to 0. So this x bar is equal to median is equal to mode or equal in this case. Okay, so the bell shaped curve which acquire the some name of the normal distribution, or you can say normal curve, so which is looking like a bell shaped curve. So while it has a wide range of application in the real world, because most of the area normal distribution they are using, okay, to find a best solution to check the probability. It has many characterizations, mathematical also. So observation called x are measured on the continuous scale, because we are finding in the continuous series, okay, lower limit and upper limit. So we are able to identify there is a range. Okay, so the group of people when we are studying, so better we are trying to go for normal distribution. Okay, so here the continuation scale, for example, so these are the example. Height, weight, time, which are related to the normal distribution, best examples. So in contrast with the binomial or Poisson distribution with the discrete event. So whatever the previous distribution which is related to binomial and Poisson distribution, which is coming under the discrete event. Now we are going, when the normal distribution is always talking related to the continuous discrete. Okay, the continuous probability. So the two probability what we studied in the last session, which is related to probability mass function. Now under normal distribution we are always call it as a probability density functions. So because we are finding a range here. So here there is one definition: a continuous random variable. Any problem, any experiment, unless we are not selecting a x series, so we are not able to go for further calculation. So x is very important. So in the continuous random variable, x is said to have a normal distribution if probability density function, binomial, Poisson, which is related to probability mass function. Now normal distribution, which is always coming under the probability density function. So PDF, okay, is given by f of x is equal to numerator 1 divided by sigma, because under normal distribution there are major two parameters. One is mu okay, and standard deviation. These are the two parameters are very important in the normal distribution. So here 1 divided by sigma root inside 2 pi e to the power of minus 1 by 2 and x minus mu from the x series, because you have identified the x series from the normal distribution. So you need to subtract minus mu, which is a population, divided by standard deviation, which is everything is based on the parameters only. So here minus infinity, one more time I am drawing this bell shaped curve, okay. So here which is coming for minus side, minus 1, minus 2, minus 3, here plus 1, plus 2, plus 3, okay. So which is nothing but mu is equal to 0 in this case, okay. So here minus infinity, which is not, this curvature is not touching, okay. So this bell shape is not touching for the x-axis. So that's what which is minus infinity. Even if you try to go for positive side, even the infinity, because this bell shaped curve is not touching the x series. So that's what which is a plus infinity. So always the standard deviations will be 0 here. So minus infinity to, okay, less than mu or plus infinity, based on the graph bell shaped curve only we are trying to identify. So with the parameters mu is equal to x sigma. So here under binomial and normal Poisson distribution also we have identified mean, variance, standard deviation. So in this case also the mean and variance here, see, mean is equal to e of x is nothing but mean, so which is always a mu, okay. When we are writing like this, which is a mu is nothing but your population mean. So variance we are writing v of x is equal to standard deviation x. Okay, in case we are trying to go for setting some standard in the normal distribution, that's what we call it as a standard normal variate. So under standard normal variate only we are trying to solve the problems. So let x follow normal distribution with parameters with mean and variance, okay. Then x is a normal variant. So x tend to n, because the numbers, the frequency total, so which is always mu comma variance. The standard normal distribution formula, because under normal distribution curve, bell shaped curve, we are setting some standard, that's what we call it as a standard normal distribution. Because here 1, minus 1, plus 1, minus 2, plus 2. So what is the area is covered, okay, in between minus 1 to plus 1 and in between minus 2 to plus 2, what is an area, the standard what we are setting here. So the formula is z is equal to, z is always denoted in the normal distribution symbolically. The formula is from the x series minus mu is nothing but population mean, divided by sigma, standard deviation, is a standard normal variant, okay. So under this formula is very important. From the x value, now we need to subtract the population mean divided by standard deviation, okay. So here the standard normal variant with always the parameters mu is equal to 0, standard deviation is always 1, you must remember in this case. So that is z is equal to normal distribution 10 to n, because the value is given, mu value 0, which is starting from 0, and standard deviation, because you are able to find out in the left side and right side, left side minus sign and right side plus sign. So the standard deviation always 1 here. So where z is equal to, in this case the z is equal to z scale, or you can say z transformation, okay, from this x, which is nothing but the desired value of the observation. So using the x series x value only we are trying to go for solving the problem, and mu is nothing but mean of the distribution or population mean we can say, and sigma is nothing but standard deviation of the distributions here. Moving forward, so here the property of a normal distribution or normal curve, it is the expected question, okay. So the theory part which is related to what are the properties we are able to identify in the normal distribution. The first one, okay. So here one more time I am drawing this bell shaped curve, okay. Here plus infinity and minus infinity. Now the first one, the normal curve is always looking like bell shaped curve, okay. Bell shape curve, mu is equal to 0, x bar is equal to median is equal to mode. Now, it is a symmetric. Symmetric means what? Left and right side equally divided means which is a symmetry. The peak also we are able to identify. So the peak, this graph is looking like a symmetric because both side equally distributing. So in a normal distribution, mean, median, mode always equal because equal in this case. So third one, for a normal distribution, standard deviation or sigma, because we are writing in this case minus standard deviation. So how we are writing here? So next slide you are able to get more clarity. So because there are two parameters are very important in the normal distribution, mean, mu, or mu and standard deviation. So here the standard deviation symbolically we are writing sigma. So in this case, normal distribution quartile deviation. So 2 by 3 into standard deviation. 2 by 3 into standard deviation. In this case, mean deviation 4 by 5 sigma. So fourth property, the first and third quartile are equal distant from the median. Okay, we are able to get there are three quartiles, Q1, Q2 and Q3. This is quartile related problem because we need to find out the position. For that reason, quartile is very best suitability. So in this case, the median, okay, the Q3 and Q1 which is equivalent to the median. So that's what which is an equal distance. For normal distribution, Q3 plus Q1 minus Q3 divided by 2 which is always equivalent to median. So Q1 how we are getting? Mu minus 2 divided by 3 sigma because left side, okay, the quartile 1 is going for left side. So that's why the sign is very important. And next Q3 value mu plus 2 by 3 into sigma. So which is going for the right side. So here the Q3 value we are getting right side. Moving for fifth property, in a normal distribution, P is equal to P of X is equal to C. C is nothing but your constant value. So 0 for all C value, 0 for all C value where C is a constant value. Okay. So sixth property, the curve is asymptotic. The curve is asymptotic means what? This curvature is not touching the x-axis. Which is not touching the x-axis means which is always going for asymptotic, which is not touching the x-axis. So the curve touches the x-axis at infinity. Infinity means which is going still it is extending. Okay, so we cannot give direct full stop here, any specific point. So that's what which is an infinity. In other words, the curve does not touch the x-axis. Okay, so the curve what we are drawing which will keep on extending. Okay, otherwise it will be not touching. Seventh property, the point of inflection occur. The point of inflection occur. See left side, right side, which is starting from first one mu minus sigma. That means 1 sigma. Again, if you try to extend mu minus 2 sigma. Okay, so like this minus and plus which is going for 3 standard deviation 1, standard deviation 2, standard deviation 3, and right side also we are getting a positive value. So standard deviation plus 1, plus 2, plus 3. If you are seeing the next graph, you are getting a more clarity how much the area is covered. Okay, what is the central limit is set for standard. So where the curvature changes its direction. See now the curvature means now it is going like this. Okay, so again it is going like this. So which is nothing but the curvature. This is graph bell shape how it is. Okay, so change its direction. Eighth property, the distribution is always mesochotic. That means what? Equally divided. Left side, right side equally divided. So the peak we are getting here. So which is a central point. Okay, so equally dividing both side, left and right side. So that's what mesochotic. So ninth property, the total area under the normal curve is unity. Unity is always 1. The total graph which is always having a 1. Okay, the total area is covered 1. Unity means 1. So here there are 3 standards are setting the bell shape is equally divided. In this case, x bar is equal to median is equal to mode central point, okay, so which is nothing but 0. So now when you are writing mu is equal to 0, the standard deviation is always increasing 1, okay, plus direction and minus direction. -1 standard deviations to plus standard deviation, the total area is covered for 68.26. If you divide it by 2, equal part will be getting 34.13, left side and right side also. This is the left tile and right tile, or left side or right side, equally distributing. If you try to go for -2 standard deviation from year to year, the area is covered for 95.44%. Again, equally divided means which will cover from left side 47.72 till 0. And again, the same area is covered for right side 47.72. Both are, if you add together, you are getting 95.44% is. If you try to go for -3 standard deviations to plus standard deviation, the total area is occupied around 99.73%. Divided by 2, if you do, you are getting left side 49.87 and right side also you are getting 49.87. So now the remaining area, how we are getting, so the total always you need to assume 100%. From the 100%, the maximum area is covered till minus sigma to plus sigma. So 99.73, if you subtract the remaining area right side and left side, we are getting 0.27. Equally divided for both sides, we are getting right side we are getting 0.135 and left side also we are getting 0.135. If you make a round figure, we can write a 0.14, both side also we can write. Okay, this is approximately we written. Moving forward. So there is one question which is related to normal distribution, how we can identify which is looking like a normal distribution with the examples. Let us assume the distribution with the population mean. So which is symbolically when we are writing population mean is always mu, okay, of the 200 unit. Okay, now which is given mu is equal to 200 is given in the question, okay. So based on the information only we can decide which is related to normal distribution. And the population standard deviation is 10 unit is given. Okay, we know the formula z is equal to x minus mu divided by standard deviation. So we need to identify whatever it is required in the formula. So we are getting x, mu value is 200 and standard deviation value is 10 is given in the question. Okay, again I have clearly in this question also specified. Then the question, what is the area between 190 and 210? Now 190 we can assume x1, 210 we can assume for x2. We need to do for separately. The given information I have written here. So what and all? Here mu is equal to 200 which is given in the question and standard deviation is given in the question 10. And x1 is given in between you are finding because which is looking like a continuous series. Okay, so when you are writing like this 190 to 210, that is also looking like continuous series. Now between which is always going for continuous series. So here x1 is identified 190, x2 is identified because according to formula we need to get an x value which is there in the question, x1, x2 separately we are calculating, and mu also it's applicable. And let us convert x1 into z variant. Z variant means what? Normal variant we are converting. So when we are converting a normal variant, we need to consider the formula. It's very important here. So the formula I have written, okay. First we are trying to go for x1 190. 190 minus mu value is given in the question 200 divided by standard deviation place we are writing 10. If you subtract, we are getting minus 10 divided by 10. So here the answer will be 1. So in this bell-shaped curve, the total area is covered because 190 which is going for left side. So exactly mu is located for whatever given information mu is given which is locating for the central point 200, 190 which is going for left side. The total area is covered for 100%. Okay. So in this case using the 1, okay, to find out the value. So let me go for say x2 value simplification. The formula is standard second x2 is given 210 minus 200 divided by 10. So you are getting right side. Plus sign is always going for right side. So using this, after getting this answer, we need to refer the table. So it means that 190 and 210 are at a distance of 10 from the mean of ordinate. So that means the distance what we are getting. Now we have to find the area between 190 to 210 or 190 to 200 left tile, and one more time we are going for right tile. Left tile and right tile. So what is the area is covered for minus sign and what is the area is covered for plus sign. So 190 to mu is given 200, so which is exactly located for mu, okay, the central value. So what is the area is covered? How we can get to know after getting this answer? Using the table, normal distribution table we are referring here. So here minus infinity 190, which is exactly minus infinity to 0. Here one more, and also area between 200 to 210. So when we are writing, okay, so 0 to plus infinity. 0 to plus standard deviation. So right side we are referring. So this particular one, how we can refer the table? So here exactly 1.0 is there. That means in front of 0 is there. So we need to refer the table. So for that reason, how we are getting the refer table? See, under normal distribution, okay, after getting the calculation, we are getting one answer. Okay, so we need to refer the table. From the Z table, 1 is exactly here. Okay, so 1.0, the first answer will be 0.4313. Okay, using a normal distribution. Okay, after simplifying, after getting this answer 1 we got. So in front of 1 0 is there, the first column we need to read 0.3413. So for that reason we are referring a table. So see, easily we can identify the one value 0.3413. So now we are writing. So referring the normal distribution table, we found left side also equally we are getting 0.34134. Okay, and left side, which is 190, means which is always going for the bell shaped curve. So left side minus 190 and exactly here 200, here plus 210. Okay, now left side, that's what we are writing the value which is using a Z table value 0.3413. So left side value also we are getting 0.34134, and even the right side also we are getting value. So 200, which is nothing but 200 to 210, or you can write 0 to plus infinity. The value also both side we are getting. So if you add together the total, we are getting 68.268, which is already in the property, in the last 9th property we identified. So 68%. So now we are writing the area covered between 190 to 210. The in between means till here you need to read. So now we are taking the total together, we are getting 60 fraction value 0.68. We can write in the percentage 68.27%. That's what we mean by plus or minus sigma covered 68%, because here minus 1 sigma, here plus 1 sigma, the value we are getting. So the area is covered. Moving forward, there is one more question. What is the probability that the worker selected at random from a group which is related to normal distribution earn wages between, again we identify which is related to normal distribution. Okay, so one criteria, group which is normal, and between also which is related to normal. So here first 180.4 and 219.6. okay, there are two x values given. The first x1 value 180.4, second x value 219.6 rupees. Given that the mean wages, mu wages, that means population mean, it is very important. Mu also given in the question 200. Okay, and again the standard deviation is given 10. We know the formula z is equal to x minus mu. divided by standard deviation. Now the question further, if there are 500 workers, why they are giving? To find out the expected frequency, expected probability. So that's what. Now capital letter N also is given, 500 workers. Okay. How many of them will have wages between 180.4 and 219.6? Out of 500 workers, how many of them are getting this in between these wages? Now whatever the information is given, I have written given information. Mu 200 is given, standard deviations 10 is given, x1 value, the first value x1 180.4, x2 value 219.6, the n is given, 500 worker is given, so capital letter N. Now converting into Z scale or Z score or normal variant. So using the standardizing formulas, Z is equal to x minus mu divided by x. Now separately we need to do the first one, x series x1 value, next x2. So first one we are trying to go for x1 value. So x plus we are writing, the formula x plus we are writing 180.4 minus mu is given in the question 200 divided by 10. If you subtract, we are getting 19.6 divided by 10. We are getting 1.96. Again, we need to refer the table. Okay. So because the area is covered only 1, the total area value is 1 only. So using the table, we are getting the value. Okay. So next one, Z, second x variant is 219.6 minus 200 mu is given divided by standard deviation. If you simplify 19 here plus sign, here minus 19.6 divided by 10. Now finally we are getting plus right side. Okay. So this one is the left side and this positive is always going for right side. Now we need to write the scale here. So here which is starting from bell shape is starting from the year. For example, the bell shape graph one more time I am writing. So here minus 1 and plus 1 and plus 2 minus 2. So like this will be extending. Exactly mu is located here 0. Okay. So in this case the total area is covered 180.9 to 219.6. How much is covered? So we need to identify using the reference table. Okay, normal distribution table. Now 1.96 we got minus side, 1.96 plus sign right side. So moving forward, so here according to corresponding Z value we got 1.96. Okay, again we need to refer the table. So we will get the value for 1.96. The value is 0.47 5. See, when you try to go for, see the first value 1 and second, so 1.6 which is located for here left side, again right side also which is located. If you try to go for shading this area, so the total area is covered, so the value is also given, the total value for left side and right side. Left side separate value 0.475. Okay, so again the bell shape karo, left side this value, here 1, here 2, in between it is located, that's what the value is totally 0.475. So which is applicable for left side. So here we identify 180.4, here we identified 219.6 till here the area what we identified. So the area both side we are getting 0.475. Okay, we can refer the table also 1.96, which is something where the graph is extending. Both side we are getting the table what we referred, the same thing we need to identify. So left side we are getting 0.4750 and right side also we are getting 0.4750. If you add together till to here minus 1.962 plus 1.96, the area is covered, the total 95%. Okay, so how many workers are working between the 180.4 to 219.6? So in this case expected probability we need to find out. So the probability what we are getting in this, if you are adding together 95%, so 0.95. So n, so expected frequency formula is very simple, n into p. So n is given in the question 500 into probability what we calculated. If you multiply we are getting 475. That is your expected frequency. Keep on watch for next section. Thank you.